We carry the sum of human knowledge in our pockets, yet technical research feels overwhelming. Information is abundant, but actionable insight is difficult to extract. A typical project now involves a chaotic collision of dense academic PDFs, scattered YouTube lectures, and fragmented meeting notes spread across dozens of open tabs. A single human brain cannot manually cross-reference hundreds of pages of documentation and hours of video content within the deadlines of a modern professional environment. The primary bottleneck in R&D is synthesis, the difficult process of turning raw, disconnected data into a coherent and actionable strategy. When faced with this volume of data, the reflex is often to feed it into a general AI model and ask for a quick summary. These models are trained on the entire public internet. While they possess vast generalized knowledge, they lack a rigid anchor to the specific user-provided reality of your project. If the data is missing, they are prone to filling the gaps with plausible but incorrect guesses. In high-stakes fields like legal review or R&D, verifying a single hallucinated claim often takes longer than simply reading the original source from scratch. Google's NotebookLM represents a different architectural approach. It creates an isolated research environment where the AI's memory is restricted exclusively to the documents you choose to upload. This diagram shows the structural difference. On the left, generic models pull from unverified global data. On the right, NotebookLM operates as a closed circuit. Reliability in professional research is built on these constraints, anchoring the AI to a verifiable truth. This workflow graphic demonstrates the benefit of that grounding. You can upload entirely different formats into a single workspace, pairing the factual rigor of a technical patent PDF with the intuitive explanation of a YouTube video. Behind the scenes, the system automatically transcribes the video audio, indexes the text, and cross-references the two sources without any manual tagging required. The dense text provides the technical constraints, while the video provides the conceptual intuition. Together, they create a unified understanding that is more comprehensive than either source could provide on its own. This precision relies on retrieval-augmented generation, a three-step pipeline acting as a grounded researcher. First, it breaks documents into searchable chunks. Second, it retrieves only the exact chunks relevant to your query. Finally, it generates an answer with citations linking directly to the source. Direct citations provide a clear path back to the original evidence, ensuring that every AI-generated claim can be validated by a human editor. Most chat interactions are transient. When the window closes, the research is lost. High-level analysis requires a permanent, evolving record. This schematic shows the strategic use of the Save to Notes feature. When the AI identifies a critical numerical range or generates a novelty summary, you pin it to a permanent knowledge board. Over time, this transforms scattered queries into a customized study guide that exists independently of the chat history. Processing the data builds the foundation, but the final stage of the workflow is materializing that analysis into a form stakeholders can actually use. This diagram maps the studio interface, where NotebookLM acts as a transmutation engine. With one click, it converts dense input into 8 distinct specialized formats. On the left, the passive reinforcement options turn dense technical text into a conversational audio podcast or narrated video lesson. On the right, active mastery deliverables generate adaptive quizzes and flashcards to verify actual comprehension. This automated process solves the synthesis bottleneck by producing immediately usable outputs tailored for any audience. To see this in practice, consider an R&D team analyzing dense competitive technical patents. Traditionally, this requires a grueling manual effort to compare patent claims side by side and map technical differentiators. This workflow table shows the acceleration. By uploading 5 technical patents, the system instantly extracts novelty claims and identifies the whitespace across the entire set simultaneously. The result is a presentation-ready comparison matrix that provides the R&D team with verifiable data for executive decision-making. By utilizing a grounded engine, a researcher can condense hours of exhausting technical cross-referencing into a reliable 15-minute workflow. This pipeline schematic shows how advanced users bypass manual uploads entirely, using terminal commands to pull bulk YouTube data straight into their workspace. This creates immense leverage, turning a messy web search into a structured knowledge base without manual data entry. Passive reading lacks the structural retention needed for professional work. A more effective approach is the active synthesis of constrained, verified intelligence. Anchored to original evidence, the speed of your technical analysis is limited only by the quality of the sources you choose to provide.